Welcome to the AI Research Roundup. I'm Alex, and today is May 7th, 2025. Alright, so today we're looking at Taming the Titans, a survey of efficient LLM inference serving. This research paper, from Hugging Face's trending list about 9 days ago, explores making LLM inference. That's the process of actually using these models to get results more efficient. It tackles memory and compute hurdles by surveying optimization techniques. Okay, so this first figure gives us a bird's eye view, really. It visually lays out the paper's entire structure, categorizing methods into instance level, like managing the KV cache. That's key value cache for attention. Then there's cluster level and emerging scenarios like RAG, which is retrieval augmented generation, or MOE, mixture of experts. It's a roadmap for all the techniques discussed. Alright, following that overview, this figure details the LLM inference process itself, typically repeated for multiple layers. It splits into two phases. First, prefill, where the entire input prompt, like the quick brown fox, is processed in parallel. This involves multi-head attention, MHA, for weighing word importance, and feed-forward networks, FNN. Then comes decoding, generating output tokens sequentially, reusing that key value cache. This distinction is key for many optimization techniques. So building on that prefill and decode distinction, this next figure dives into instance-level optimizations. It's a taxonomy, detailing approaches like model placement, request scheduling, and crucial KV cache optimization for that attention mechanism. And then there's PD disaggregation, which cleverly separates compute-heavy prefill from memory-bound decode. Alright. These are all key strategies to boost efficiency for each individual inference request and tackle those resource demands. Okay, so moving up from single instances, this figure lays out a taxonomy of cluster-level strategies for LLM inference serving. It details approaches like cluster optimization, especially for heterogeneous resources, and different types of load balancing, such as heuristic or predictive scheduling. And then there's cloud-based LLM serving. Even touching on cooperation with edge devices, it's really about managing multiple instances efficiently across a system. Alright, so moving beyond general instance and cluster strategies, this figure dives into emerging scenarios. It's a taxonomy for optimizing specific tasks, like long context, RAG, and MOE, which we saw in the initial overview. It also covers LoRa, that's low-rank adaptation for efficient fine-tuning, and speculative decoding, using draft models for speed. This highlights how specialized optimizations are evolving for different LLM applications. Okay, so rounding out their taxonomy, this figure covers miscellaneous areas crucial for LLM inference serving. It branches into 5 key aspects: hardware optimizations like mixed precision or specialized NPUs, that's neural processing units. Then there's privacy, simulators for evaluation, fairness in resource allocation, and finally, energy efficiency. These are all important supporting considerations for robust and responsible LLM deployment, complementing the core optimization techniques we've discussed. Alright, so pulling all these threads together, from instance-level tweaks to these broader miscellaneous areas, the authors conclude that significant progress has indeed been made in taming LLM inference. The core challenge remains achieving low latency and high throughput despite huge memory and compute needs. Their systematic review, covering everything from optimizing individual requests to managing entire clusters, really charts the advancements. Thanks for listening to AI Research Roundup. I'm Alex.